So this is using the slicing method to find the area or the volume of a certain solid. The description of the solid is pretty general, pretty nondescript. So here's the idea, right? You have a solid whose base is the region bounded by the curve y equals cosine x and the x-axis. So you have, first of all, if you were to put this on xy, the y equals cosine x, or y equals cosine x function looks pretty much like this, but this is an area. When we're talking about volume, right, we're saying that if you do x, y, z, we're saying that this little semicircle looking thing, which is not really a semicircle, but it looks like one, is on the floor, like on the ground, like that. And above each of those, we're drawing little triangles. And those triangles will vary, right? The height of each of those triangles is going to be vertical like that, and those triangles will vary. They're going to get smaller and smaller based on the distance between this and the y coordinate. So this is, if you trace all of this, it's going to get you a solid, so something with volume. And the volume then, from the slicing method, is the area of the cross sections from minus pi over 2 to pi over 2. So that's how the slicing method works. You integrate the area of the cross sections, and the cross sections are these triangles. So we're really integrating areas of triangles, so base times height over 2. So what is the base, right? Look at each of those triangles. This guy, if you bring it out, the base is the distance, this horizontal distance right here. So that is the y coordinate, right? Which is cosine x. In this drawing, this is the base of my triangle. And if I were to draw in this plane right here, it says if my triangle is standing upright on top of the paper, and this red line that I see here is the only thing I can see of it. The height that you'll have will be the same because I'm told that it's isosceles, right? So the height is also cosine x. Now if I wanted to change this, I could probably say, oh, the height is twice the base, or 10 times the base, or half the base, or the height is, I could give a different expression for the height. I could say the height is 2x. I could say that if I wanted to. But what matters is that now, because it's isosceles, this equals this, right? So it's actually not cosine but root cosine, right? That's what was given to us. We were told that was root cosine. So then that's root cosine x times root cosine x over 2 dx. So that is 1/2 integral minus pi over 2 of cosine x dx. So all that's left for me to do is antiderive this guy. Do the sine of x, right? The derivative of sine equals to cosine. So the antiderivative of cosine is sine. And then I evaluate that from minus pi over 2 to pi over 2. That is the fundamental theorem of calculus. And then the answer will be sine of pi over 2 minus the sine of minus pi over 2. So that is 1/2 times 1 minus minus 1. So that is 2 over 2. So the answer, final answer here is 1. See, finding the answer is not really the cool part. The interesting thing is to be able to show clearly how you got the answer. And that's what I want to see in a test.